Hello, our next topic is prioritized sweeping. So far we have seen DynaQ architecture. DynaQ means it is a combination of model based plus model free. So in the DynaQ architecture we follow three steps. First is finding the Q values from each and every state. Second is based upon this Q value we are building a model. Third one is whatever suppose in this state I got some Q value. Based upon this Q value I am simulating same kind of experiences, same kind of values, same kind of state actions reward. Again same, here I have some Q value. Based upon this Q value, again in this planning step I am simulating same kind of actions and whatever the rewards it will get same. Everything here it is happening simulation. But in DynaQ what it will happen from each and every state I am simulating the experiences in the planning step. Here if I am there I am simulating the experiences of this state. Again here. So here we are simulating the experiences for each and every step. So it takes more time to do. So this is the drawback in the DynaQ. Just to overcome this drawback, we are moving into our next algorithm, which is prioritized sweeping. So prioritized sweeping, which is an enhanced version of the DynaQ. With this technique, we are adding one smart planning technique. Smart planning. So what is that smart planning? Here we are simulating the normally DynaQ what we are doing for every state we are simulating the similar kind of experience, but in prioritized sweeping we are seeing the Q values of each and every state which has the highest value. For those states only we are simulating the similar kind of experience, that is prioritized sweeping. So for every state actions we are not simulating the experiences. Now we will see how it will work. So before going to see how prioritized sweeping works, we will see one technique called temporal difference. We will see what is temporal difference. Temporal difference means normally just like in Q learning, what we are doing in Q learning, we are calculating the Q value when an agent in each and every state. Here I will calculate the Q value. Here I will calculate the Q value by taking the Q learning algorithm formula. So what I do, suppose here I have calculated some Q value. I am predicting this might be the Q value in the next state. Both I am subtracting the predicted Q value with the actual Q value and I am checking this temporal difference value. Suppose see here, now I am here, agent is here, I am calculating the value function like Q value of this one. With I am comparing with I am predicting this might be the Q value in this state. So this is the predicted, this is the actual. So I am subtracting those values from the next state predicted minus right now current Q value, that is the delta T. So if it is positive, it means the outcome is better. How it means positive, how the outcome is better? Suppose now I am predicting the next state Q value as 20. And current is 3. So if the difference is positive, high positive, it means we are considering these values. If we see the next state predicting, I am predicting as 20, but it is originally as 10 only. So the delta value is very less actually. So in the priority sweeping, what it does, instead of simulating the experiences for each and every state action, which state action has the temporal difference is very less. So which state don't have much difference, like it might be equal, the predicted and actual, those kind of state actions values are only we are considering. So we will see how it goes. So in prioritized sweeping, the first step is DynaQ. How DynaQ we will take state action reward next state that we are taking. Second, that is first step, Q values, but just first considering Q values. Second, based upon the Q values we are model the environment. Now after that we have to calculate the temporal difference value. Temporal difference means I am predicting the Q value of the next state with the current state. Then if it is very large, it means then we are adding this next state action where I am adding into the priority queue. If it is very small means I am not adding into my priority queue. It means in prioritized sweeping we are maintaining one queue. So for which state action the delta value is high, those particular state and action, those particular state I'm keeping into the queue. If it is very less delta means I'm not taking the state action into the queue. So now so far just like DynaQ, we performed Q value, we model the environment. Now we will see how we are planning. So in planning, we are just taking for which state action the delta value is high. Those values we are taking into the queue. Then again we are performing the queue update. Again see. Now again we are calculating the temporal difference. If the delta value is high means we are pushing that into the queue. So if you see, we are not simulating the experiences to each and every state. We are simulating the experiences for which state the Q value is high. For those kind of things only we are simulating the experiences. It means it learns little bit more faster than the DynaQ.